Test for aldehyde ketones. Test for aldehyde and ketones. One of the important test is 2,4-DNP test. 2,4-DNP test. If it is positive, 2,4-DNP test is positive, that means the reactant is either aldehyde or ketone, because both aldehyde and ketone react with 2,4-DNP. And here we get colored compounds. Here we get colored compounds, and the color can be yellow, orange, and orange red precipitate. So it confirms the reactant has either aldehyde or ketone. So we know the basic reaction. Aldehyde, when treated with 2,4-DNP, 2,4-dinitrophenylhydrazine, it is a 2,4-dinitrophenylhydrazine. This reaction happens in slightly acidic medium or slightly basic medium. Slightly acidic medium or slightly basic medium. So simply what will happen here, remove the H2O and it give finally corresponding 2,4-dinitrophenylhydrazone derivative, and which is colored PPT. Similarly ketone also react with 2,4-dinitrophenylhydrazine, in the presence of slightly acidic or slightly basic medium. Remove the H2O and form corresponding 2,4-dinitrophenylhydrazone derivative. 2,4-dinitrophenylhydrazone derivative. Similarly, hemiacetal and hemiketal also. It is a hemiacetal or hemiketal. If one group is R, another group is hydrogen, that is hemiacetal. If one group is R, another group is also called also there, then hemiketal. Even this one also react with 2,4-dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine in the presence of slightly acidic or basic medium, because we know that hemiacetal breaks into corresponding aldehyde or ketone plus alcohol in the presence of acidic or basic medium. హెమిఎసిటాల్ హెమికీటాల్ ఎసిడిక్ మీడియంలో ఫామ్ అవుద్ది, బ్రేక్ అవుద్ది. అలాగే హెమికీటాల్ కూడా ఎసిడిక్ మీడియంలో ఫామ్ అవుద్ది, బ్రేక్ అవుద్ది. సో ఇక్కడ మనకి ఎసిడిక్ మీడియం ఉంది కాబట్టి ఆర్ బేసిక్ మీడియం ఉంది కాబట్టి మనం ఏం చేస్తాం, ఫస్ట్ రివర్సిబుల్లో బ్రేక్ చేస్తాం. బ్రేక్ చేశాక ఆల్డిహైడ్ ఆర్ కీటోన్ వస్తుంది and remove the H2O, and finally it gives corresponding hydrazone derivative. And it is also colored compounds. So by observing the color we can say the reactant can be aldehyde or ketone. Of course we can also add hemiacetal and hemiketal. Hemiacetal or hemiketal. Suppose the reaction not happening at room temperature. In case ఒకవేళ రూమ్ టెంపరేచర్లో రియాక్షన్ జరగకపోతే స్లైట్గా మనం ఆ రియాక్షన్ మిక్స్ని హీట్ చేస్తే then reaction possible. After a few minutes we can observe the color. It is a 2,4-DNP test. The importance of 2,4-DNP test is it confirms the reactant has either aldehyde or ketone or hemiacetal or hemiketal. Next one is halo form. Especially we use iodoform test. Especially we use iodoform because iodoform CHI3 is LOPPT. LOPPT. Now the iodoform test is if the reactant has this kind of structure or the reactant has this kind of structure. When we add iodoform reagent I2 plus OH minus, OI minus, I minus plus IO3 minus, I2 plus CO3 minus 2. We can use any one of these reagent. So here simply how to write the answer? It undergo CC bond cleavage. Now this part undergo oxidation. Therefore corresponding product is COO minus, since it is a basic medium, and the CH3 part will be converted into CHI3. So it confirms the reactant has this kind of structure. It confirms the iodoform formation confirms the reactant has this kind of structure. First one. Second one, even active methylene also. This active methylene also. But in the active methylene the condition is both sides either aldehyde or ketone it should be present. Now it is treated with the iodoform, same reagents. Now this active methylene part converted into iodoform. This active methylene part converted into iodoform. We have to break the CC bond. We have to break the CC bond. It will be converted into carboxylic acid. It will be converted into carboxylic acid. And third one is if the reactant has this kind of structure, CH3CO leaving group or CH3 CHOH leaving group. Even though it is having structure like this, because of leaving group it do not give iodoform. Because of leaving group it do not give iodoform. Next, fourth one, suppose active methylene at least one side is leaving group is present, again because of the leaving group it also do not give iodoform test. So it is about the iodoform. So iodoform mainly useful in examination point of view. It confirms the presence of this group in the structure or it confirms the presence of this group in the structure. In this way it is mainly useful. Next one is toluenes AgNH32OH or AgNO3 plus ammonia or AgNO3 plus NH4OH. So this is called, these two you can call it as a ammonical silver nitrate. Ammonical silver nitrate. It is a toluenes reagent. Toluenes reagent. Next one is Fehling solution. Next one is Fehling solution. Fehling solution A, Fehling solution B. Fehling solution A is copper sulfate. Fehling solution B is sodium potassium tartarate plus NaOH. And this sodium potassium tartarate also known as rock-LA salt. Rock-LA salt. It is a Fehling solution. And here Cu plus 2 form complex with the sodium potassium tartarate, COO minus, CHOH, CHOH, COO minus, COO minus, CHOH, CHOH and COO minus, and here Cu plus 2 and here Cu plus 2. So it is a ligand, dative bonds here with oxygen. So it is a copper complex. So it is a Fehling solution. Next, Benedict solution. Benedict solution A, CuSO4. Benedict solution B, sodium citrate plus NaOH. So sodium citrate is COO minus, sodium citrate is COO minus CH2, COO minus OH, and CH2 COO minus. It is a citric acid derivative. So in the Fehling and Benedict, mainly we talk about Cu plus 2. In the Fehling and Benedict, mainly we talk about Cu plus 2. In the Tollens, mainly we talk about Ag plus. In these three reactions, the common factor is it is a basic medium, it is also basic medium. So all these are basic medium. First point. Next one is generally Benedict solution is more stable than Fehling. అంటే మనకి ఫెహిలింగ్ సొల్యూషన్ కావాలంటే ఇన్స్టెంట్గా ప్రిపేర్ చేసుకోవాలి ల్యాబ్లో. బెనడిక్ట్ అనుకోండి, ఫర్ ఎగ్జాంపుల్ ఇవాళ ప్రిపేర్ చేసింది మనం రేపు కూడా టెస్ట్ పర్పస్లో వాడచ్చు. సో ఆ సెన్స్లో బెనడిక్ట్ సొల్యూషన్ ఈజ్ మోర్ స్టేబుల్ దాన్ ఫెహిలింగ్ సొల్యూషన్. Now we talk about our main reactions. Suppose aldehyde treated with Tollens reagent. Tollens, mainly we talk about first Tollens. When it is treated with the Tollens lo Ag plus and OH minus. So here aldehyde undergo oxidation, any aldehyde undergo oxidation and Ag plus undergo reduction. So all aldehydes, it gives silver. అండ్ ఇక్కడ మనకి సిల్వర్ అనేది ఏదైతే మన బీకర్లో మనం రియాక్షన్ చేస్తామో ఆ గ్లాస్ బీకర్ వాల్స్ మీద సిల్వర్ లేయర్ ఫామ్ అవుతుంది. దట్స్ వై ఇట్ ఈస్ కాల్డ్ సిల్వర్ మిర్రర్ టెస్ట్. సిల్వర్ మిర్రర్ టెస్ట్, ఆల్సో కాల్డ్ టోలెన్స్ టెస్ట్, and it is a redox reaction. It is a redox because aldehyde is oxidized and tollens is reduced. Similarly, hemiacetal also. It is a hemiacetal. We know that hemiacetal in the presence of basic medium through E1CB mechanism, proton and leaving group, it forms corresponding aldehyde and alcohol. Now this aldehyde part undergo oxidation in the presence of Tollens reagent. It gives corresponding carboxylic acid and silver mirror. So both aldehydes and hemiacetal give the Tollens test. But ketone do not give the Tollens test. Similarly, hemiketal also, even though it is unstable in basic medium, but it produces finally ketone only and alcohol, and we know that ketone do not undergo Tollens test. So aldehyde and hemiacetal respond positively to the Tollens test, and ketones, hemiketals do not respond positively, they respond negatively. Similarly, aldehyde treated with Fehling or Benedict, in both we are having Cu plus 2. Fehling or Benedict in the presence of basic medium. So this aldehyde oxidized to carboxylate and Cu plus 2 reduced to Cu2O red PPT. So aldehydes also give Fehling test, but here one of the exception is aromatic aldehydes. Aromatic aldehydes do not give Fehling and Benedict. Aromatic aldehydes do not give Fehling and Benedict. Similarly, hemiacetal also, in the presence of OH minus, react with Cu plus 2. Hemiacetal converts into aldehyde plus alcohol through E1CB mechanism. Now aldehyde undergo oxidation, converts into carboxylate, and Cu2O red PPT will form. That means both aldehyde and hemiacetal respond positively to the Fehling and Benedict. The only exception is aromatic aldehydes and aromatic hemiacetals. Aromatic aldehydes and aromatic hemiacetals do not respond positively to the test. Similarly, ketones, like in the tolerance test, ketone and hemiketal also do not respond. So the overall conclusion is Tollens, Fehling, Benedict, aldehyde, Tollens positive, Fehling positive, Benedict positive. Next, aromatic aldehyde, Tollens positive, Fehling negative, Benedict negative. Hemiacetal, Tollens positive, Fehling positive, Benedict positive. If the hemiacetal connected to aromatic ring, Tollens positive, Fehling, Benedict negative. Now remaining ketones, hemiketal, and of course acetal, and of course ketal. So these functional groups do not respond positively to the Fehling solution and Tollens test and Benedict test. So from this we have to understand mainly, if aldehyde is present, that is undergoing oxidation. Even in the simple aldehyde, even in the hemiacetal, if aldehyde is we are getting, then reaction possible. If aldehyde is not possible, aldehyde is not there, then reaction is not possible. So this is related to aldehyde ketone chapter, and remaining functional groups also we are having, we will discuss it after this. So this is about the mainly aldehyde and ketone chapter. Next one is Schiff's test. Schiff's test is simply we will take the aldehyde or hemiacetal, and we add Schiff's reagent, para rosanilin chloride, in the presence of H2SO3. Restore its pink color. The reagent para rosanilin chloride restore its pink color. It confirms the presence of aldehyde or hemiacetal. Suppose if I take ketone and hemiketal, there is no pink color appearance. So this is about mainly Schiff's test. Now we will see the reaction. So it is a para rosanilin chloride, benzene, NH2, NH2 plus Cl minus. It is a para rosanilin chloride. Now it reacts with H2SO3. So this nitrogen and this carbon, both, and this nitrogen. So these three react with the corresponding sulfur, and finally it gives corresponding NH2 SO3H NHSO3H, sorry, SO2H, not SO3H, here SO2H and here SO3H. And here NHSO2H. It reacts with aldehyde, 2 moles of aldehyde, sulfur nucleophile attack, pi bond shifted. Therefore, the final structure is double bond, NH2 plus HSO3 minus, double bond, and here corresponding aniline NH, S double bond O, CHOH, R, aniline part, NH, S double bond O, CHOH, R. సో ఎప్పుడైతే మనం ఆల్డిహైడ్ యాడ్ చేస్తామో, ఆల్డిహైడ్ యాడ్ చేసినప్పుడు ఈ పారారోజానిన్ క్లోరైడ్ అనేది రీస్టోర్ ఇట్స్ పింక్ కలర్. ఈ ఫైనల్గా ఫామ్ అయిన కాంపౌండ్కి పింక్ కలర్ కూడా ఉంటుంది. సో దిస్ ఓవరాల్ రియాక్షన్ ఇండికేట్స్ ద ప్రజెన్స్ ఆఫ్ ఆల్డిహైడ్ ఆర్ ద ప్రజెన్స్ ఆఫ్ హెమిఎసిటాల్. It won't confirm the presence of ketone and hemiketal. It mainly confirms the presence of aldehyde and hemiacetal. So that is a Schiff's test. Now the remaining reactions of Tollens, Fehling and Benedict. First functional group is aldehyde. So aldehyde, when I add Tollens or Fehling or Benedict, aldehyde functional group will be oxidized to RCOO minus. With Fehling, silver will deposit. With Fehling, red PPT will form, and with Benedict also red PPT will form. First functional group. Second functional group is hemiacetal. So in the presence of basic medium, it loses alcohol, form aldehyde. Now this aldehyde undergo oxidation. Finally, it gives corresponding carboxylate. Second functional group. Third functional group, alpha hydroxy ketone. This is a alpha hydroxy ketone. Now when it is treated with the Tollens or Fehling or Benedict, this alpha hydroxy ketone oxidizes to diketone. Fourth functional group, carboxylic acid, only formic acid. Formic acid undergo oxidation, gives CO2 in basic medium, it converts into carbonate. But remaining carboxylic acids, no reaction. That is fourth functional group. Fifth functional group is N-hydroxyamine. Nitrogen contains hydroxy, N-hydroxyamine. Tollens or Fehling or Benedict, it undergo oxidation, it gives corresponding nitroso compound. Fifth functional group. And the sixth functional group is alpha hydroxy ketone, primary alpha hydroxy ketone. Now it won't undergo direct oxidation, it undergo tautomerization and converts into RCHOH CHO. సో ఇక్కడ టాటోమర్ కాన్సెప్ట్ వల్ల ఇక్కడ మనకి ఆల్కహాల్ వస్తుంది, ఇక్కడ ఆల్డిహైడ్ వస్తుంది. సో ఇలా కన్వర్ట్ అయిన తర్వాత రిమైనింగ్ ఆల్డిహైడ్ అనేది ఆక్సిడైజ్ అవుతుంది. రిమైనింగ్ ఆల్డిహైడ్ అనేది ఆక్సిడైజ్ అవుతుంది. సో ప్రైమరీ ఆల్ఫా హైడ్రాక్సీ కీటోన్, primary alpha hydroxy ketone. With respect to CO, it is alpha, it is primary carbon. So primary alpha hydroxy ketone. So these functional groups we have to remember. టోలెన్స్ ఫెహ్లింగ్ బెనెడిక్ట్ క్వశ్చన్ ఇచ్చాడు అంటే ఫస్ట్ ఫంక్షన్ గ్రూప్ ఆల్డిహైడ్ గురించి మనం థింక్ చేయాలి, సెకండ్ ఫంక్షన్ గ్రూప్ హెమీ ఎసిటాల్, థర్డ్ ఫంక్షన్ గ్రూప్ ఆల్ఫా హైడ్రాక్సీ కీటోన్, ఫోర్త్ ఫంక్షన్ గ్రూప్ ఓన్లీ ఫార్మిక్ యాసిడ్, ఫిఫ్త్ ఫంక్షన్ గ్రూప్ ఎన్ హైడ్రాక్సీ ఎమీన్, సిక్స్త్ ఫంక్షన్ గ్రూప్ primary alpha hydroxy ketone. So in all these cases, toluenes, when we add toluenes, silver deposited. When we add Fehling or Benedict, red PPT Cu2O will be deposited. And one exception for Fehling and Benedict, aromatic aldehydes and aromatic hemiacetal. These two compounds do not respond to the Fehling and Benedict, but these two compounds respond to the toluenes. So this is about the test for aldehydes and ketones.